This project is something called a loop antenna. Now in old days the loop antenna used to be like a loop, actual loop and two fed points to it. And what we are going to design is for application called RFID, which is a radio frequency identity, and it is a free communication. It has two modes. One is near field, where you have your magnetic reader, you have your card, you keep it in your vicinity. The primary will be charging the secondary in the card, and then there will be a code. This ID will be there, which could be a pre-programmed or programmable ID, and then whatever is the code written inside will be transmitted back. So it's basically transformer action and coupled with a communication. So that is a near field, and in a far field you will have two poles like you see in the malls, and there will be a RFID tag attached to some suit or something like that. And if you try to take that suit out of this zone, there will be a scanning zone. As soon as this RFID tag arrives here, it will start buzzing. So we are planning to use this RFID concept. There are two different antennas required. You must have seen there is a round patch, which is an active antenna, and there is something called as passive antenna. Active antenna requires batteries, and if that battery dies down, then your tag will be of useless. So daily they have to check whether the tag is working or not. Similarly, in the case of near field, you have to move so near to the tap so that you can tap the card actually. So it's hardly 10 centimeter or something like that. So the antenna we are designing is basically a microstrip patch antenna. Now patch antenna will have loop something like this. So it's not actual microstrip patch unlike this full of copper, but it will have something like a hollow structure of a copper, and then this becomes your simplest loop antenna, and then you can calculate the length of loop by calculating these dimensions. So basically this antenna design requires some software called IE3D, and which is an antenna simulator. It will generate some graphs, directivity, attenuation, etc. And basically we need to test it for near field and far field. So this is the near field effect, this could be the far field effect, and the antenna should work for both. So practically what we are going to do is going to design a copper clad with a technology called screen printing, and maybe something called as photolithography. So on a substrate glass epoxy, we are going to design an antenna, which is a loop antenna, and these dimensions will be computed. Mainly the design will be carried out in AutoCAD, and then there is a photolithography and some process called screen printing. And then the antenna will be tested for the desired frequency at a near field and at a far field, and this could be the simulation result it will compare. So this is how this project works.